Halo Pak.
Halo Bu.
Selamat datang kami ucapkan kepada Ibu Koordinator Bilingual dan juga
Iya,
Bapak Speaker,
kabar.
orang. Selamat datang juga kepada Bu Marini Damani.
Oke.
Wah, lumayan juga yang gabung ya. Banyak ya?
Pak. 900 lebih Pak.
Wah, bagus juga
Iya. Ini saya tadi dapat laporan udah 974.
Aduh, mantap.
Selamat datang. Selamat datang juga.
Halo, Michael.
Hai Michael.
Hello, good morning.
Thank
Good
you.
afternoon from Indonesia, Michael.
Here in Austria is morning.
What time is it now there?
8:30.
Oh,
All right.
okay.
So we have a very nice, cool weather here. At the moment, it's not so hot.
All right, right. That's good.
Oh ya?
Sunshine.
Nice
Marini,
to
you
meet
remember
you.
the nice days?
Nice to meet you, Michael. Thank you so much.
I'm pleased to meet you. I'm pleased to be with you.
Okay.
How are you, Michael?
Fine. Here in Austria, everything is fine.
Okay.
So we have started some new projects.
Okay.
And we are growing mushrooms at the moment. And algae.
Microalgae.
Yes.
Okay.
Spirulina.
Yeah. How about the COVID-19 there? You already like isolation? I mean, the people just keep at home or they can go surrounding?
We have, the institute is working normally, but the students are not so welcome here.
Okay.
So they have to stay at home until end of August. And all the teaching, or practically all teaching, is done on the internet.
Yeah, the same here too. We will start
Okay.
at the lecture on September. So by daring, I mean by online.
Okay.
Teaching.
Yeah, it's like here, everywhere the same.
Yeah.
See? We also in Medan very good. The weather
Yes.
now still dry and sometimes rain season.
Okay. So we had, these are the first warm days.
Right.
Let's say, so we have the last 2 weeks, we had warm weather and a little rain at the moment. So yeah, but this changes every day. It's no constant. But for the moment, there are no clouds, beautiful blue sky. That's it.
Right, right.
Marini, my lecture will start at 9 o'clock. Is this? I don't hear you. You have turned off your microphone, Marini.
Yep.
Okay, sorry.
You will be the second speaker. So the first is Deemas, and then afterwards you will go, because we will directly speaker 1, speaker 2, and speaker 3, and then afterwards we enter to the question and answer session. Is it okay for you?
Perfect.
Okay.
Perfect.
Thank you.
Thanks.
Yeah. Hello, Deemas.
No responding.
He is not listening. It's just a picture.
Hello, ma'am. Sorry, there's something problem with my laptop.
Yeah.
Hello, Professor Michael, Professor Maniar, and all my lecturer there. Nice to meet you too.
Nice to meet you, Deemas. We are happy to hear you there.
Same with me here, sir.
I'm pleased to meet you too.
Yes, Prof.
Baik, kepada Bapak dan Ibu peserta webinar, kita akan memulai acara pukul 13.45 WIB. Untuk itu, saya informasikan bagi peserta yang mengalami kendala dalam mengakses Zoom, bisa dapat mengikuti international webinar melalui live streaming YouTube. Berikut saya sampaikan beberapa peraturan yang harus diikuti oleh peserta webinar. Yang pertama, diharapkan untuk menonaktifkan atau mute mic selama webinar berlangsung. Yang kedua, untuk sesi question dan answer, bagi peserta yang ingin bertanya melalui Zoom, dapat menggunakan fitur Q&A yang terdapat pada Zoom. Bagi yang ingin bertanya melalui live streaming YouTube, kami akan menyediakan link yang akan dibagikan saat acara webinar berlangsung. Yang ketiga, peserta harus mengisi form absensi sebagai bukti keikutsertaan dalam acara webinar ini melalui link yang akan dibagikan pada saat acara webinar berlangsung. Dan yang terakhir, peserta harus mengikuti webinar hingga akhir sesi dikarenakan panitia akan membagikan link sertifikat pada akhir acara. Terima kasih. Sebelumnya, selamat datang kepada Ibu Dekan Fakultas Matematika dan Ilmu Pengetahuan Alam, Ibu Dr. Fauzia Harahap, MSI.
Good afternoon, Bu Fazia.
Tapi orang lihat ya.
Yeah.
Afternoon, sir. You can see me?
Yeah, it's clear. Michael already with us. Deemas also already with us. Bu Dekan.
Yes.
Michael, Fauzia is our dean in Faculty of Mathematics and Natural Science, Universitas Negeri Medan.
Yeah.
Okay.
Good afternoon, sir.
I'm pleased to meet you.
Okay. It's nice to meet you too. Michael Coffee.
So we are waiting for the moderator to start, isn't it?
Mohon izin Bapak Ibu, kami akan memulai acara. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. We are delighted to welcome you to International Webinar Bilingual Program in Universitas Negeri Medan, Indonesia. I am Nadia Ulfa as the Master of Ceremony of this international webinar. Her Excellency, the Dean of Mathematics and Science Natural Faculty, Dr. Fauzia Harahap, the Vice Dean of Academic, Professor Herbert Sipahutar, the Vice Dean of Administration and Finance, Professor Mukhtar, the Vice Dean of Student Activity, Muhammad Yusuf Nasution, MSI, our speakers, Professor Manihar Situmorang, State University of Medan, Indonesia, Professor Michael Murkovic from Austria, Dr. Kandidat Deemas F. Simatupang, Polytechnic of Industrial Chemical Technology, Indonesia, Bilingual Coordinator Program, Dr. Ellie Julia, Leader of Mathematics, Physics, Biology, Science, and Computer Science Department, and also all participants of International Webinar Bilingual Program 2020. Excellencies, participants, ladies and gentlemen, we are now going to listen to the opening speech delivered by the Coordinator Bilingual Program, State University of Medan. Ladies and gentlemen, please welcome Dr. Ellie Julia.
Thank you, Nadia. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, I'm indeed very pleased to welcome all the participants who come from west to the east of our country. Allow me to report that about 1 participant registered and attended this webinar. Keynote speakers, Professor Manihar Situmorang, Professor Michael Murkovic, and our proud candidate doctor students, Deemas Simatupang. As part of our faculty who promote science and mathematics education in our university, our bilingual programs has a mission to enhance quality of science and mathematics education graduates by developing high quality program and exchanging knowledge and expertise from local until global issues, including sustainability. Because sustainability development goals is our concerns in the global world. It is my sincere hope that this webinar will spur the exchange of our knowledge, collaboration, and networking among participants. So, on behalf of our staff and management of the bilingual program in our faculty, I would like to acknowledge the supportive hands of these purposeful efforts and express our gratitude to our Dean of our faculty, Ibu Dr. Fauzia Harahap, our committee, our conference partners, our contributors who have made this webinar possible. Wishing all participants have an enriching knowledge and expertise. Thank you so much. Wassalamualaikum warahmatullahi wabarakatuh. Back to Nadia, please.
Thank you, Dr. Ellie Julia, for the opening speech. Excellencies, distinguished guests, participants, ladies and gentlemen, now we are going to listen to the opening speech delivered by the Dean of Mathematics and Natural Science Faculty, State University of Medan. And afterward, we would like to request the Dean to officially open the International Webinar Program 2020. Ladies and gentlemen, please welcome Dr. Fauzia Harahap.
Thank you for the opportunity, Nadia. Assalamualaikum warahmatullahi wabarakatuh. First of all, let us express our gratitude to Allah Subhanahu wa Ta'ala, the God, the Almighty, who has given us uncountable mercy and blessing so that we can attend this graceful occasion, chemical application, realizing future sustainability. The Honorable, our information sources, our speakers, Professor Manihar Situmorang, MSc, PhD, from Universitas Negeri Medan, Professor Mikhail Murkofi, from Institute of Biochemistry, Grace University of Technology, Austria, Prof. Taku Liyama, Physical Chemistry Laboratory, from Shinshu University, Japan, Professor Deemas, Dr. Candidate Deemas F. Simatupang, MSc, from Biochemistry, Biotechnology Polytechnic of Industrial Chemical Technology, Indonesia, the Honorable functionaries within our faculty, the Faculty of Mathematics and Natural Sciences, especially Head and Secretary of Bilingual Program, Dr. Ellie Julia, MPD, and Dr. Marini Damanik, our student, especially Chemistry Education, Bilingual Program, and all webinar participants who have joined this link. Ladies and gentlemen, today we know that the sustainability challenge is to develop innovation and policies that allow humanity to meet current and future environmental, human health, economic, social need, and etc. The chemistries, government, lecturer have many roles in sustainability. It provides chemical, material, and technologies that improve the safe and efficient use of energy and natural sources, and its responsibility for delivering them in a way that protects human and environmental health. Chemistry in laboratory, classroom, and industry, it is a central science for development of sustainable technology and innovation. Today, we will listen to deeper and detailed presentation about chemical application realizing future sustainability from our speakers. Finally, by saying Bismillahirrahmanirrahim, I open the webinar Chemical Application in Realizing Future Sustainability. Assalamualaikum warahmatullahi wabarakatuh.
Warahmatullahi wabarakatuh.
Thank you, Dr. Fauzia Harahap, for the opening speech. Excellencies, participants, ladies and gentlemen, we would like to invite to all of the speakers to the screen to deliver their speech. The speech will be moderated by the Secretary of Bilingual Program. Ladies and gentlemen, please welcome Dr. Marini Damanik.
Okay, thank you, Nadia. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Ma'am, first, the speaker.
Sorry, okay. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good afternoon, ladies and gentlemen. I would like to say thank you to all of you that joined with this webinar with the theme Chemical Application in Realizing Future Sustainability, which supported by Chemistry Education Bilingual Program and Mathematics and Science Faculty of State University of Medan. An honor to meet you here in this webinar. Let me introduce myself. My name is Marini Damanik. I will be a moderator for all this session. All speakers who are, the first speaker is Dr. Candidate Deemas Prananta Simatupang. The second speaker, who is Professor Michael Murkovic from Graz University of Technology. And the third speaker, who is our Vice Rector from State University of Medan, Professor Dr. Manihar Situmorang, MSc, PhD. So I will introduce for the first speaker, Deemas Prananta Simatupang. Deemas, who is lecturer from Department Chemical Engineering, Polytechnic of Industrial Chemical Technology, Ministry of Industry, Medan, North Sumatra, Indonesia. He is an alumni from Chemistry Education Program Bilingual 2009. He got some awardee from PPA Indonesia government, awardee from Dikti Scholarship, and now on he become like awardee LPDP Scholarship to continue the PhD program at Bandung Institute of Technology, Indonesia. And then some award that he already got, which is Best Speaker in Chemical English Session in the International Scientific Meeting on Engineering and its Vocational Education in Makassar 2019, Speaker for Preparation of Doctoral Study, UPI Bandung at 2018, and then he is the cum laude for the graduate and then undergraduate program from ITB 2016, and then from FMIPA State University of Medan at 2013. We invited Deemas with an effort that rose the enthusiasm of his junior classmates to keep on studying and intend to continue their education to the highest level and then go abroad. And then publication and research experience, which is related to the enzyme, which is resistant to the high temperature. Without further talking, the topic of Deemas is thermozymes as potential biocatalysts for industrial application. For Deemas, I will give you 15 until 20 minutes to present your presentations, and then the time is yours.
Okay, thank you, Ma'am Marini Damanik for the introduction. Assalamualaikum warahmatullahi wabarakatuh. Shalom bagi kita semua. Om Swastiastu, salam kebajikan, and peace be upon you. I would like to express thank you for the committee Chemistry Education Study Program, Bilingual Program, for giving me a chance as a speaker to present a topic in this international webinar. I think it's like a reunion for me because as moderator said, I am an alumnus from this bilingual program at 2013, and I'm very happy to meet you again, all my lecturer in State University of Medan. especially for the speaker, Professor Mania Sumarang. Hello, Prof. Actually, Prof. Mania Sumarang was my undergraduate thesis supervisor, and he actually delivered many knowledge to me, and then to become like this. And then nice to meet you too, Professor Michael from Austria. And then thanks for all participants that attend for this international webinar. And I hope you are in good condition in this pandemic situation. Well, I will show my screen. Okay. Now do you see my screen and my voice is clear for you? Hello, Ma'am Marini. Do you see my screen?
No, we didn't see your screen, Deemas. Could you please repeat it again? We didn't. Okay.
Okay. Do you see my screen now?
Okay. It's okay. Okay.
Okay. Thank you. Okay. Well, my presentation is entitled about the thermozymes as potential biocatalysts for industrial application. As moderator said, actually I am a lecturer at the Department of Chemistry, Chemical Engineering, Polytechnic Industrial Chemical Technology in North Sumatra. And I'm also a doctoral student in Bandung Institute of Technology. I joined with the Biochemistry Research Group. And this topic actually is a part of my dissertation research project. So you may familiar with this topic. I will explain a lot of terminology in biology. So maybe some of the terminology is doesn't but I will explain later. Actually, my presentation will last about 15 until 20 minutes. So if you have a questions, I'll be happy to answer them at the end of my presentation. I open my presentation with my favorite quote. Don't limit your challenges, challenge your limits. So don't give up for all of your problem. Dream it, believe it, and then do the best for it, and you will be got what you want, and you will be a successful person. Okay, I divided the topic by several main points. The first is about what is actually the thermozymes. Thermozymes is a kind of enzyme. We can isolate it from the thermophilic microorganism, and they can live in a high temperature at a range 41 until 122 degrees Celsius, and they actually have capable of accepting petrolysis and living in the extreme situation. This thermozyme actually have a physical properties and then can maintain the electrostatic interaction and different living in a different adaptation because they can keep their activity at the great temperature. We can isolate them from the hot spring, mountain area, and the composting. The reason why our research group in Bandung Institute of Technology use this because Indonesia has a lot of volcanoes. If you can see in the screen, the map of the major volcanoes in Indonesia. So we believe that Indonesia will have a biodiversity of the thermophilic microorganism and also the biodiversity of the thermozyme. The kind of thermozyme that usually researched by the expert, the first is the thermostable lipases, and this lipase is also as the subject point that we research in the ITB. So we have our professor have many collection of the thermostable lipase that we selected from the hot spring and the mountain and also compost. And the other type is esterases, amylases, and then cellulases, proteases, silanase, chitinase, and manganase. For this topic, I will focus on only the thermostable lipases, and I will explain you and describe how we can get the thermozyme, or we can clone or subclone them to get a pure thermozyme and then have the high gas activity. So thermostable lipases, what is actually the thermostable lipases? Thermostable lipases has a specific character. They can maintain itself in a certain condition, such as stable in the high temperature and in organic solvent. we can isolate it from the thermophilic microorganism. Actually, lipase can catalyze the hydrolysis of triacylglycerol, become glycerol and free fatty acid, and also can react with the esterification reaction, interesterification, transesterification, and separation of racemic mixture. So the uses of this thermostable lipase used widely in the industrial applications, such as for the cosmetic industry, detergent, pulp, medicine, and also for biodiesel. So the second point is, how do we get the thermozyme itself? First, we can get the thermozyme. Actually, we can apply the cultivation method and the metagenome method. If we apply the cultivation method, in the final, you will get the pure colony bacteria that contains the gene encoding the thermozyme. If you use the metagenome method, you doesn't have a pure single colony of bacteria, but you have a DNA fragment which encoding the thermozyme. So for example, this I use the cultivation method here. So I got the enrichment culture, and then I dilute again in the specific grow until many times. So after that, we make a specific media, yeah, and then we inoculate. It's about 100 curd sample, and then we shake them, grow up them in the incubator with a certain temperature. It's also 15 until 100. So we enrich them until two or four times, and then after that we take 100 microlite and we spread them in the agar plate. After that, we incubate them into a agar plate, maybe overnight, 1 until 2 days. We can get the target bacteria. The target bacteria, we can predict that it deliver the gene encoding the thermozymes. After get the target bacteria, we use this technique, strict method, to get the pure colony bacteria. So if you ever took the microbiology subject, you will familiar with this method. So after we get the pure single colony bacteria, we have to determine what species for the bacteria. So we have to extract the whole genome or DNA, and we use the primer. Yeah, this is the Reagan PCR. In the pandemic situation, I believe that you ever heard the terminology of PCR. PCR, or polymerase chain reaction, is a machine that can amplify much of the gene. Yeah, and then for the identify, we use the primer 16S rRNA gene. And then we have to prepare the DNA as a template, primer, DNTPS, polymerase, buffer, and PCR tube. We do the PCR, and then to visualize the DNA band, we use the agarose electrophoresis method. After we got the DNA band, we have to sequence them to align the sequence, and we use the biotools by using the in silico analysis to determine the species of this colony bacteria. After we know the species of the bacteria, we actually take again the single colony, and then we put it in the specific media, we grow up, and then all of the liquid media we centrifuge, and the supernatant we analyze the lipase activity by using the colorimetry method. We use actually the spectrophotometry vivis. We analyze for the certain condition. For this sample, one of collection in the ITB research group, there is one isolate called as ITB 1.1. We analyze them by using the colorimetry method, and the lipase activity is 0.0045 unit per milligram. We think that this is still a low lipase activity, so we want to increase the lipase activity. So we take the cloning method. So we have to produce the recombinant thermozyme or recombinant thermostable lipases. So here we have to prepare the bacteria cell. So we have to extract the DNA fragment, such gene that encoding the thermozyme. We have to amplify them, and we have to design the specific primer that insert of the restriction site of the enzyme. And then we have to prepare the cloning factor, or we call as the plasmid here. Actually, cloning factor is a circular shape, so we have to cut it first, and then with the extraction enzyme, and then we insert the gene interest into the plasmid. After that, we ligate, and then we put it in the bacterium. Actually, we have the E. coli top 10, and then we let it grow in the specific medium. Overnight, we can get a million cell of E. coli top 10 that deliver the gene encoding thermozyme. After that, we have to prepare another factor called as expression factor. So this is the picture. In this picture, we can see there is a donor plasmid, it's a cloning factor, and the recipient plasmid is an expression factor. So we have to get it again between the donor plasmid and the recipient plasmid with the specific restriction enzyme. And then we, after cut, we insert again the gene interest them, we ligate, and then we get the new expression factor, and we do the specific the same technique with previous one. Okay, this is the kind factor or plasmid we use in our laboratory. We use the cloning factor PZ 1.2 and then PET30A for expression factor. So after that, we use the same technique, and we got the lipase activity higher than the wild type one. So the lipase activity of this ITB 1.0 is higher than before. It is 0.25 unit per milligram, sorry, and is higher than the previous one. So it increased about 55-fold. If we want to increase them, we have to purify this recombinant thermozyme by using the affinity chromatography. Because we use the expression factor that fuse with the polyhistidine tag, so it easily purified by using this nickel and Ta affinity chromatography. So if you take a look for this picture, all of the target protein is bind with the nickel and Ta, and then wash it. After that, all of the complex protein mixture will release, and we elute the target protein with the ferrous concentration of imidazole, and all the protein that has already purified, release, and we analyze with the same technique, lipase assay. So after the purification, we got the lipase activity is higher than the crude, increased twofold, but our research group think that this is still low, so we have to search the other alternative expression system. So the other alternative expression system, we choose the Pichia pastoris, is kind of yeast. If we change the host cell, so we have to change the expression factor. And we do the same technique, but this time we just clone them. We just subclone from one factor to another factor, and we put it into the host cell, and we visualize by using the agarose electrophoresis to see the DNA band. And if we want to insert into the yeast, Pichia pastoris, we have to linear the recombinant plasmid by using the heat shock or maybe electroporation. We plate in the agar, and then we visualize again. And we do the same technique for measure the lipase activity. So for this experiment, the lipase activity is increased. It's about 11-fold from lipase activity which expressed in E. coli system. And we analyze the protein band by using the SDS page electrophoresis. After that, we have to purify all the thermozyme, thermostable lipase, and then we have to characterize them to see which thermostable lipase or thermozyme meet the industrial requirement. So we have to characterize them by a parameter of pH detergent, substrate specificity, temperature to see the thermostability, organic solvent. Okay, this is the publication from my research group in ITB. So it's about the lipase gene, and this also for thermostable lipase. And actually, this is my work during my doctoral degree, and this is the recent study. Okay, I think that's all of my presentation. I will introduce you my research group that I joined with them. This research group actually guided by two professors, Professor Amaloka PhD and Professor Vida Madayanti Warganegara PhD. And this is the picture of our team. Okay, if you have any question, maybe after this presentation, you may discuss with me by this email. This is my contact details. Well, thank you for listening, and I give it back to moderator.
Okay, thank you, Deemas. Very interesting. Okay, we will keep the question after the three speakers already present their presentation. So we will enter to the second speaker, who is Professor Michael Murkovic. Michael Murkovic was born in Graz in 1959 and was studying technical chemistry at Graz University of Technology with a focus on biotechnology. He finished his diploma and PhD in the field of biotechnology in 1989. As a postdoc, he stayed for 1 year in Switzerland at ETH Zurich and continued his professional career at pharmaceutical company Biochemie Kunde or now on Sandoz in Austria. In 1993, he moved back to Graz and started working as a food chemist at the Institute of Biochemistry and Food Chemistry at Graz University of Technology. His research focus is in the formation of carcinogenic compounds that are formed during cooking and the influence of antioxidants on the formation of these compounds. And then he's specialist in liquid chromatography and mass spectrophotometry and habilitated in 2002 and become associate professor in the field of food chemistry. Current projects are on the production of mushroom on spent coffee and production of biomass using microalgae. He has published around 100 manuscripts in review scientific journal, and then he's teaching food chemistry and food biotechnology at Graz University of Technology, Medical University of Graz, and University of Applied Science. Besides his university affiliation at TU Graz, he is active in the food chemistry division of EUChem's European Chemical Society, and is currently chairman of the Austrian Food Chemists. This is not the first time Michael is here. In 2015, he had come here at State University of Medan directly and already toured surrounding Lake Toba and Brastagi. And at that time, already gave a short lecture at State University of Medan. And then now on, he returning back to State University of Medan through this webinar. Thank you for coming back to Indonesia by online, Michael. And then, without further talking, today he will talk about challenges for sustainable food production in the changing climate. Michael, I give you 15 until 20 minutes to present your presentation. Now on, Michael, the time is yours.
Thank you, Marini. It's very nice to be back in Indonesia, even it's only a digital visit. So let's go to my presentation, which is not really the topic of my research, but some ideas that I think might be of interest, not only for me, but this is a general topic for the whole world. I hope you can see my presentation.
We didn't see it yet, Michael. Could you please repeat it?
Okay, I'll try again. Here, okay. Now you can see it.
Okay, it's okay now.
Good, now it should work. Good. So the changing climate, I think it's something that we do not really have to discuss, because we know that because, I mean, the reason is difficult, but it's mainly because of the human activity on the Earth, and we see the rising temperatures. You see on the top two pictures from before 2000, some kind of temperature distribution, and after 2000, the temperature distribution, and we see a temperature increase. And this temperature increase is a result of the increasing concentrations of greenhouse gases in our atmosphere. As you can see, the lower picture, that, for example, the carbon dioxide is increasing significantly since the 1950s. So before the 1950s, it was more or less constant for several thousand, 10,000 years, and now the concentration has increased. And this increase on, let's say, greenhouse gases, carbon dioxide, methane, and so on, is the reason for the increasing temperature on practically any place in the world. And the increasing temperature means that especially the food supply is becoming more and more a problem, because agriculture and food production has to adapt to this changing climate. We have, and you will see some of the problems that are associated with this increased temperature. For example, when we talk about food, water is one of the main foods that we need, of course, for drinking, and we need it also for food production. When we calculate how much water we need for food production, it's very easy to calculate how much water we need, because for 1 kilocalorie of food, we use about 1 liter of water. So you just multiply by the amount of calories you eat every day, and then you know how much water is needed for food production. And if this water changes, and we need very high quality water for food production, because it has to be clean, it has no toxins, should not contain any toxins, no pathogenic organisms, whatever. So the quality has to be extremely high, and this high quality water is limited. And the higher temperatures, of course, the result of the higher temperatures is that we change the water circulation in the world. We have higher water temperatures in the oceans, higher evaporation, meaning that we have in some areas more rain. And here, let's say, this data that are shown here is that, the distribution of water is changing. We have, in some areas, we have more dry weather, and in some areas we have more rain and more intensive rain. Snowing in the mountains is extremely important because the water is retained during the cold season, and this is a resource of fresh water for the warm season. More intensive rain, of course, is a problem because the erosion of the soil is becoming more and more problematic. We have a similar situation not only with water, but also with food, and we have to adopt agriculture and food production to this changing climate conditions, because we have increased temperatures, we have more water stress, more dry, more wet, more water. Plant diseases are changing. We have more fungi growing, plant pathogens, bacterial plant pathogens, and so on. They are destroying the harvest by a big extent, and this becomes more and more problematic when the temperature increases. And of course, due to higher temperatures in general, the distribution, temperature distribution, air pressure distribution in the atmosphere is more extreme than at lower temperatures. So we have more weather extremes, we have more rain, more wind, more dry regions. Good. the change in the food production is not only a problem for the farmers, but for the whole community, for the whole population of the world, because everything might change and we have different areas that have to be used for agriculture, and the land use for living is becoming more and more problematic because of the increasing population on the earth. So, what impacts do we expect from a climate, from the changing climate? As I said before, we have more extreme weather conditions, and these weather conditions is not only a problem for the crops, but also for the livestock. So animals that are farmed, like cows, sheep, and so on, it's more problematic because of the high temperatures. The storms that devastate farms induce erosion, induce landslides, and so on. They all reduce the agricultural production. There are some data of some examples from the United States. You see that after flooding and huge areas of flooding, the soil was covered with just a few meters of sand, and this has to be removed, or a new kind of agriculture has to build on top of this sand. And this takes time, and of course is extremely expensive. On the other hand, the increasing temperatures in a moderate climate means that different plants can be farmed, meaning, for example, that soybean production can extend it to the north, because soybean is very temperature sensitive, and when the temperature during the growing season, the temperature is reduced below 12 degrees centigrade, the harvest will be reduced by around 30 to 50%. So when the temperature is increasing, we can move soybean production further north, for example. The water distribution, water scarcity. So we have the problem that drought can occur in big areas on one hand. And of course, you know that the lack of water can easily damage and destroy crops, dry up the soil, and of course, the basis for living is lost. Here are some numbers from California. It is estimated that around 3.8 billion American dollars of economic loss because of the very dry weather. The next part is that the seasons are changing here. I mean, in the regions around the equator, you have more or less a constant season with more rain, less rain, constant temperatures. But when going north, you have very pronounced seasons with cold winter. I think Marini remembers the cold winters that we have in Austria. And the warm and hot summer, so the temperature changes, being that the winter is not as cold anymore, and the summer is getting hotter and more humid here. So the crops also have to be adopted, the varieties have to be adopted to this changing. When the plants start flowering earlier, and the weather changes and the extreme weather changes. So we have high temperatures and extremely low temperatures, and the plants can be destroyed during this very extreme temperature changes. Wildfire, you know from the news that, for example, in the western part of the United States, or last year in Australia, there was a very huge and extended wildfire that not only devastated the plant growing areas, but they also have, because of the smoke, which is distributed, you know that in the smoky areas working is very difficult, and the smoke also influences the quality of the foods that are produced in these regions. Here is, for example, the wine production. Because the smoke aroma on the wine, this is completely ruining the quality of the wine or of practically any other produce. When we talk about rising CO2 levels, of course, this is inducing higher temperatures, but some of the plants or most of the plants can handle increased CO2 levels. They are producing more biomass, they're producing more products, they have higher metabolism with increasing CO2 levels, so the productivity can be higher when we have a higher CO2 concentration to a certain extent. Not any plant can withstand any CO2 concentration, but this, let's say, this moderate increase of CO2 can be handled very nicely by the plants. Good. The greenhouse gas emission is also a problem from food production. On one hand, from food waste, which is degraded, and methane is produced during, let's say, composting, for example, or during degradation with the microorganisms. And of course, also the greenhouse gas emission, or methane emission from rearing of animals, especially from cows. Yeah, so this is a very important sentence, because the food production is not only affected by the climate change, it also induces or is contributing to the climate change. You see that this IPCC, it's mentioned here on the last picture down here, the Intergovernmental Panel on Climate Change, gives a report, and they say that 20% of the CO2 emissions are from agriculture. So this contributes a lot to the greenhouse gas emissions. Another problem with the increasing temperatures is that we have to cope with more pathogens, human pathogens like Salmonella, Campylobacter, Listeria, Vibrio, as it's mentioned here. We have to think of higher concentrations of mycotoxins in the foods, so especially in the cereals, or in fruits and fruit juices and so on. You have an increased presence of toxic fungi. Good. How is it the impact on our food? When you look at, for example, at the homepage of the Food and Agriculture Organization of the United Nations, you see that especially the food insecurity is a problem for the poor countries, where food insecurity is more present than in the richer countries, and this will be affected much more during the climate change. The food production has to be increased by 60%. And you can imagine we produce a lot of food, but to increase food productivity by 60%, to cope with the growing population, this is a big, big challenge for the future. It seems that there will be a reduced productivity because of the climate change. Fish species will change, and some might be reduced, especially those that are commonly harvested for food. So some of these species will be reduced significantly. The problem of deforestation, forest degradation also contributes to the greenhouse gas emission. So you see we have here an increase of from 0.4 to 1 billion tons of CO2 per year after the 1990s. Yeah, agriculture is contributing with methane to the greenhouse gas emission by up to 80%. Yeah, so we have a lot of problems that we have to challenge in the, let's say, in the next years, and we should try to solve these problems. So the Food and Agriculture Organization also publishes this kind of key facts, which should show very, in very nice, not very nice, but in very intense pictures how the climate will change and how the impact will be. One interesting point is here that due to reduced flow of the rivers, the salt water will into, or rising sea level, reduced flow of the rivers, the salt water will intrude back into the rivers, and the area where salt water is influencing, the coastal area, which is influenced by salt water, will be increasing more and more, which also has an effect on the agricultural productivity. This sentence is already mentioned before. Grassland also will be reduced by higher temperatures. As I mentioned earlier, the snow in the mountains, especially in the high mountains, is reduced, and if the snow and the ice, which keeps the water for the warm season, so that we have enough fresh, high quality water during the warm season, this will be reduced. Yeah, this also here, the increased yield of 7 to 15% is a result of improving the varieties that are used for productivity, for production, and of course for optimized. When you use optimized irrigation, you also can increase the productivity. Good. We have some impacts here. You see from these are some data from Europe and from North and South America, so from the American continent. They estimate that the yields of the major crops will decline during the next dozens of years. The climate might favor the fruit production because of higher temperatures and not so cold winters. This is also, and the stress in the southern regions on soybean production, the heat stress is also increasing. Reduced precipitation restricts water availability. The heat stress on the animals will reduce the milk production and weight gain. So productivity in animal farming is becoming problematic. With the increased temperature in moderate areas, the productivity can be increasing, and with the higher CO2 concentrations, there's a higher productivity. Yeah, in South America, there is salinization problematic, increasing the salt concentrations in the soil. And of course, because of the deforestation, the growing areas of the deserts, desertification is a big problem in South America. Okay, and when we look at the data which are expected for the Asia, also from the FAO, they estimate that the agricultural zones will shift northwards because the water availability is reduced in the south. In the southern areas, the higher temperatures will also influence the rice productivity. Lower rain also will influence the rice productivity. And then there is, of course, a higher demand for irrigation because we need higher food productivity. And in these arid and semi-arid areas, which could be used for food production, but they need more intensive irrigation. And the heat stress on the animals in the hot areas also will reduce the possibilities to expand or to increase the productivity for animal production, so for meat and milk production, for example. So with this few data, I just want to show that we have some challenges for the near future. We have limited water availability, or we will have limited water availability. The changing climate will induce changes in the agriculture so that we will have to change the areas where we produce food, and we have to change the varieties that are produced, and not only the varieties, but also the species. So we have to use different species that are grown in different areas. And with this, I want to thank you for your interest, and I hope there will be some questions which I can answer later. Thank you.
Thank you, Michael. So we will go further for the third speaker first, and then afterwards we will go to the question and answer set. Okay, and then for the third speaker, last but not least, the third speaker, who is our Vice Rector 4 from State University of Medan, who is Professor Dr. Andes Manihar Situmorang, MSc PhD. Professor Dr. Andes Manihar Situmorang was born in Palipi, Tapanuli Utara, August 4, 1960. He already graduated from a diploma and then master and PhD degree from the University of New South Wales, Sydney, Australia. At 1986, appointed as a lecturer at State University of Medan, and then in 2003, appointed as professor in analytical chemistry at State University of Medan. In 2002 until 2003, he became a head of Research Center for Basic Science, State University of Medan, and then became a dean for 2 terms from 2003 until 2007, and then 2007 until 2011. And then become a chair of the Research Institute at State University of Medan. And then he became the second term from him from 2019 to 2023 as a Vice Rector for Planning, Cooperation, and Public Relations. Conduct research from various sources, writing scientific articles in various scientific journals, high index Scopus 10, and then high index GS 15s. Published 5 titles of textbooks, granted 2 patents, and registered 2 patents. The topic for today, he will talk about the rule of chemistry. For Prof. Manihar, I will give you 20 minutes to present your presentation. The time is yours. Thank you, sir.
Thank you very much for the time for me to share the knowledge on the application of future sustainability. Actually, as Michael said, this topic is not my research in our university, but we are happy to share with you how's the role of chemistry in realizing the future sustainability. Before I open my talk, because I look at a lot of participants join us in this seminar, our coordinator bilingual didn't introduce about the bilingual program first. So this time I want to introduce the bilingual program in the faculty. It started in 2008, and now we already have a lot of alumni all over the world, because they are separate in many universities, and now some of them have become a researcher and lecturer in Indonesia, and become a researcher in many countries. So for those of you who have families, maybe children who have a prospective student to become a student in Universitas Negeri Medan, do so, apply for bilingual program. We have it a special selection for bilingual program in Mandiri program, but for regular student, we recruit them from SNMPTN and SBMPTN. So make sure you choose this program. We have chemistry, physics, mathematics, and biology. So let me give I share my presentation. Okay. My topic is chemistry. This is I outline maybe not enough for 15 minutes, Marini. Sorry if it's a bit longer. Okay.
Okay, I will give you 20 minutes.
Okay.
Okay.
The application of chemistry in realizing future sustainability is a very interesting topic, actually. Our webinar is a good chance for us to review our commitment on future sustainability. It has to admit that chemistry has a very large contribution in realizing human welfare, because chemistry almost cover the whole aspect of life. However, the work of chemistry also has negative impact, especially those related to environmental problems if they are not managed very well. So as a scientist, mainly as a chemistry, we must support the realization of future sustainability. Look at some environmental disaster related to chemistry. It is actually very what we call damaging, not only to the environment, but also to the human life. So future sustainability become a hot issue in recent years. A lot of effort has been made globally with aims to have safe environment for everyone of us in the future. Our Earth is facing climate crisis resulted from human activities, and therefore we have to do action to realizing future sustainability. So this occasion we have to do our contribution. We call it name of the role of chemistry. The United Nations already adopted in the 2030 Agenda for Sustainable Development. There are 70 Sustainable Development Goals and associated with 169 targets for countries towards by 2030. So all the goals cover up a range. Now we have to choose what our roles now. There are 9 planetary thresholds to achieve in sustainable future. Professor Michael already discussed about climate change for agriculture. So if you look at the list now, it is related to stratospheric ozone depletion, biodiversity loss and extinction. Now, as a chemist, most of us are dealing with chemical pollution, and also for atmospheric aerosol load. And there are transformation concern with education and gender and equity for future sustainability, like health, well-being, and demography. Professor Michael already talked about sustainable food related to land, water, and ocean. And we have a lot of things that's dealing with people, planet, and partnership and peace, and a lot of issues. So this is the sustainability development goals already rise in the prosperity by 2030. And our, as a chemistry, if we look at this, there are 17 issues. So what we have to do to promote a sustainability future, we have to remember that we only have one Earth. Even though a lot of research already done, but there is a possibility to live not only in the Earth, but until now we only have this Earth. So we have to do an action. We have to do whatever the best just to look after this Earth. So we have to make it personal. Everyone has to do your contribution, especially for those of you as a chemist. So this is personal action for us. We have to think critically on everything in the activities that support future sustainability. Maybe about foods. I'm happy if we support organic and local food production. Professor Michael already tell us about water, and also those who have to think in our life. Maybe we have some money, but if we are not live in the friendly world, it is not, the money is nothing. We have to think for us and also for our next generation. And as a chemist, we have to create a knowledge and understanding and to find the solution to deal with our world. So in our knowledge as a chemist, that's cover many things. Maybe as in Universitas Negeri Medan, our core mostly are in education. We have to motivate our student in doing research and education to look after this earth. That's we have environmental chemistry there, and also laboratory safety. So now, as a chemist, we have to take our role. Okay, we have, as a chemist, we have responsibility to educate citizens to the knowledge of chemistry, and also we have to focus with the issue now, like green chemistry. In green chemistry, we need to do our action to make less waste, and also in our laboratory, we have to make it good and to support the environment. So this is chemistry. We have 5 basic chemistry: inorganic, organic, analytical, physical, and biochem. But nowadays, a lot of type of chemistry already arise and specialize. I list some up here. Maybe many of the participants graduated from one of those type of chemistry, and maybe your research is coming from this type of chemistry. But for us, we have an essential role to help to achieve the SDGs goal. Green and sustainable chemistry education may be very good for us in bilingual class, and for those of you who are in industry, green and sustainable chemistry manufacturing practice, and in the research, and many things else. So I identify there are 8 priority SDGs for us. Those are for zero hunger from those 70s, good health and well-being, clean water and sanitation, and I just made the list in the last is quality education. So for zero hunger, maybe as a chemist, we can help the society to achieve the zero hunger. We may synthesize or find safe chemicals to protect the plant. It means that when we do research, for example, we have to find friendly chemicals, those to improve food production or to extend the cell life, or if we find a preservative or packaging to make the quality and safety of food. And maybe as a chemist for zero hunger, we can focus on finding new type of fertilization or production of health food, synthesize selective crop protection agent, and many things. The second is good health and well-being. As a chemist, chemistry can achieve the good health by improving our knowledge in the invention of chemicals to defeat disease. And at the same time, we have to find the chemicals that free from hazard, or at least it has a very high value, but minimize the environmental impact. We have to reduce pollution, and also when for good health and well-being, finding a good chemicals for medicine, and also as analytical chemistry, we have to find a very fast analytical medical diagnosis, and also applying green and sustainable chemistry to eliminate and to reduce hazardous chemical pollution. For clean water and sanitation, as a chemist, many things we can do with this. Maybe invention new method on purification of water to make it faster, low price, and also deployment of greener technologies and pollution prevention strategies. Finding new low energy, high efficiency in separation method for removal metals and micropollutants, and everything in our research has to think of future sustainability and also affordable clean energy. Chemists can help affordable and clean energy through development of new materials for renewable energy. If you look at the picture in the right there, now all as a chemist we can get a very cheap material for producing energy, for like solar energy. Okay. Also for those of you who are working in industry, the chemical processing industry can improve manufacturing efficiency, and like the Deemas already find a new catalyst, and whatever our career, we have to think about future sustainability in the industries and innovation infrastructure. First, we have to upgrade the infrastructure of chemical processing industry. It should be saving energy and high productivity, but minimize pollution. We have to design and synthesize, manufacture, innovation, advancement material, and also finding research innovation for commercial application. And responsible for consumption production, we have to improve the quality and efficiency for production process, and the chemical processing industry help to reduce the life cycle of impact of consumption. Maybe we can find food packaging or additives, or maybe in waste management. And one thing is a good idea, I think, recycle and reusing molecules, because the molecule, most of them are not renewable, so we have to do it efficiently. And in climate action, Professor Michael already tell a lot of them in climate action. So my focus is green chemistry for us. Green chemistry is cover the whole language. It is multidisciplinary. So we have to think about the people, the planet, and the profit. We have to consider everything that it should be have higher valuable than the impact of the chemistry itself. So as a chemist, many things we can do on green chemistry. Those are example of green chemistry. Maybe like a well-known ozone hole, but affected by the CFCs. And now also we have to develop more efficient ways of making pharmaceutical. And this is also some of example here, I list here. And now the principle of green chemistry, actually, we have to think prevention first. Prevention. We have prevent waste, then to treat the waste. And also we have to find safer chemicals, less hazardous, energy efficient. And like Deemas already done for enzyme catalyze, we have to find a good catalysis that not affected the environment. And also we have to design for degradable chemicals. Those are the list of principles of green chemistry. For those of you, if some of you as a student, if you are doing experiment in the laboratory, you have to to think sustainable future. You have to do experiment in micro or possibly nano scale to reduce waste. If you have do research, you have to choose your solvent. Think your solvent first. If the solvent is very harm to the environment, replace it with a friendly solvent. It means the solvent itself should be degradable. And also, if you have a very toxic material, neutralize this and recycle the electronics or ice pack or whatever the material can recycle in the future. Now for quality of education, I put those in the list. Okay. As a chemist, we have a role in to achieve the quality of education. Maybe our as a bilingual class, we have to raise the standard of chemistry teacher. If possible, we can change our curriculum, or maybe the activities in the laboratory to make it adjust to the current situation now. And in our education, we have to promote the development of the knowledge and skill understanding to our student, and we have to think about future sustainability. And this is involved in different methodology. Maybe when we are teaching, we have to do many things for sustainable chemistry education. And sustainable chemistry education maybe include with green chemistry, chemical enterprise, environmental chemistry, smart material, carbon neutral economy, renewable energy resource, core chemistry knowledge, and human endeavor and local culture. So in conclusion, as a chemist, we have to realize that chemistry has its role in achieving the future sustainability. Chemistry has to be implemented through the policy, action, and our education in the class to end the poverty, protect the planet, and to ensure that all people enjoy peace and prosperity. We have to make our role from now on, and to continue to take interest in every activities and career for sustainable future. As an inspiration, let me, maybe every one of you already hear about Professor Frances Arnold. He is a laureate. Arnold was awarded the Nobel Prize in 2018 for using the process of evolution to make new and better enzyme to make fast and efficient chemical reaction. In Arnold enzyme have the potential to clean up so-called dirty process, environmentally friendly manufacturing of chemical substances in pharmaceutical and then renewable fuel. Her idea and research are dealing with sustainable future for the planet. Professor Frances already demonstrated her role to help us to live more sustainable lives, making our chemical process cleaner and greener. Now, it is our turn to contribute for future sustainability. I think that's all my talk. I'm happy to answer if I can answer. And I Go back to Marini, please.
Okay. Thank you, Professor Manihar Situmorang. Okay, I will show some question in the PPT from three of the speakers, from the audience to three speakers, and then I will show you for this one. Okay, have you looked my screen?
Yes, ma'am.
Okay, so this is one by one for the first speaker first.
Okay, I will try to answer the question that direct to me. For the first question is, what is the difference between thermozyme?
What is the difference between
Okay.
thermozyme and mesozyme about the application in industry? For example, lipase. What is different between lipase as thermozyme and lipase as mesozyme for the function in industries? And then the second one from Cindy, Bioprocess Engineering in Dell Institute of Technology. What is the difference between thermozyme and other enzyme in their enzyme activity or specific activities? And if the thermozyme using high temperature, its optimal activity, why we especially in industry might using thermozyme? We know that as higher temperature that using, as bigger energy that must applying. So have you catch the question, Deemas?
Yes, ma'am. I got it.
Okay, I will give you 10 minutes to answer this question first.
Okay, thank you, moderator, for the chance. For the first question, actually, the difference between the thermozyme and mesozyme is based on their temperature. For the mesozyme, the enzyme will active in only range temperature between 10 until 40 degrees Celsius. But for the thermozyme, they can active in the higher temperature. The range is about 41 until 122 degrees Celsius. That's the difference between thermozyme and mesozyme. So what's the function for industry? It's depend on the requirement of the industry. Like in our research group in ITB, we also get the order from like the Pertamina. Pertamina want to search the biocatalyst that can active in the high temperature to catalyze the oil become the green biodiesel. So it's depend on the industry. So for Cindy, for the first question, the difference between thermozyme and other enzyme, actually for the other enzyme, like the mesozyme, there are a different specific activity. Actually, for the thermozyme, such as thermostabiliphase, there are a thread catalytic there. It's contents of the 3 or maybe more of the amino acid that can make there in the specific activity. So they will catalyze in the certain or specific reaction. So if the thermozyme using high temperature in its optimal activity, why we must use thermozyme? Okay, actually thermozyme only active in their temperature. So in our collection in ITB, all of the thermozyme usually active higher than 50 degree until 90 degree. So the temperature is like a precursor. They cannot active if the temperature doesn't reach by them. So I think that's the answer of the question, ma'am.
Okay.
I give it back to you.
Okay, thank you for Deemas. Yeah, the question is already answered by you, the difference between thermozyme and mesozyme. Afterwards, why we use the thermozymes. Okay, we will go further to Michael. Michael, there's some question for you from Dr. Elia Julia, that Indonesia has two seasons, dry and rainy. Most people plant paddy in rice field during 3 months, so there are 4 twice harvests per year. And some local people plant paddy in 6 months for better quality of harvest. According to Weather Impact, which method of rice field method that secure and sustainable into atmosphere? And then for the second question, I would like to ask question for Professor Michael. In your opinion, what can we do to minimize the impact of climate change toward the food productions? And then the third from Saras Granita, what should we do to reduce food waste, which currently increasing every day, especially in COVID-19 condition? And how is the role of technology so that the production of food waste can be reduced? Michael, have you got the question?
Thanks. Yes.
Okay.
This is very nice that you pose very difficult questions. And they are definitely very difficult to answer. The first question is the problem of rice production. I just found one interesting number, that rice production worldwide produces between 50 and 100 million tons of methane per year. This is one problem associated with rice production. The other problem is that in some regions where rice is produced, the rain is getting less and less. So the question is, how can you solve this problem? I have no real ideas how to solve this problem, but one could be that you look for rice varieties which need less water. I mean, when you go to the rice research institutes, they will tell you how to do this, and they know which varieties use less water, and they're working intensively on this. I know this especially from Thailand, that they have varieties available that use less water. Or if there is not enough water anymore, you have to change to other crops, that starch crops, like for example potatoes. But the impact, if you change this, the impact on nutrition and the impact on eating habits will be very huge if you change from rice to potatoes, for example. So not a real answer, but some ideas that I can give to this question. The second question is how to minimize the impact of climate change towards food production. You cannot really reduce the impact. You have to cope, or you have to work on the problem by changing food production. You have to adopt all the agricultural practices to the new situation that you have. You have the new climate, you have the new weather conditions, because when you're working locally, you have the weather conditions, you have the temperatures, you have the temperature changes, you have more or less irradiation from the sun, more or less water, increasing CO2 concentrations and so on. So you have to work on the agriculture and on the food production. This is what I could say to this question. And the third question is food waste. Food waste is really a big issue worldwide, and we have in Europe big projects working on waste reduction for food. And I also can tell you a number, because I know a project from Hungary where they have done a survey on reducing food waste. And this is a big issue. in any country, but I know the numbers from Hungary, and they say that if they introduce all the measures that they can think of to reduce the food waste, they can reduce it by 10 to 12%. So reduction of food waste is a big issue. The food waste, of course, also influences the CO2 emission, the methane emission, and so on. So if you can reduce, if you have an idea how to use food waste, this would be very helpful. I mean, you have the food waste during agricultural production, you have the food waste during cooking, and you have the food waste, of course, that you have food at home that you don't eat and you have to dispose this food that is not consumed. So there are several levels of food waste, and this is very difficult to influence or to reduce the food waste. Because if you, let's say, prolong the shelf life of a certain food, you always have to know about the presence of spoilage bacteria, you have to know the presence of pathogens that are associated with this specific food. And this can be very problematic because with prolonged shelf life or with keeping your food prolonged at home in the fridge, you always have increase the risk that pathogens might be present in the food and that you get sick from eating, or even from distributing this food, other people will get sick. So yeah, two very complex questions, and they're definitely not easy to answer.
Yep. Okay, thank you, Michael, for the answer. And then because it's quite different between like Indonesia and Europe, especially for plant paddy. Okay, and then we go further for the Professor Manihar for the questions. Professor Manihar, first, what do you think the meaning of the green chemistry in your opinion? And then the second one, I would like to give another question for Prof. Manihar. Does green chemistry is the best solution for work? Does reducing waste could make Earth better? Because we are researchers will face a challenge from government policy. What Professor opinion about this? Thank you. Have you got the question, Prof. Manihar?
Yes.
Yeah.
Thank you for this question. We have to do with green chemistry here because we think the principle first that it is but prevention is the best choice for us. For example, it is better to prevent waste than to treat or clean up waste after it has been created. So, green mean here, think the value first and consider the effect. We realize that chemistry is a very huge contribution on damaging our Earth if we are not very careful on our our product. So, and also we have to think about less hazardous. So most of the lab in the world always thinking about chemical synthesis. Wherever it is practiced, our synthesis method should be designed to use and generate substances that possess little or no toxic to human health and damaging the environment. So the principle is we have to design the safer chemicals. That's I think the best choice for green chemistry. And for the second, does green chemistry is a
It's the
solution?
best solution for work.
I think green chemistry one of a good solution for us. If as a chemist, if all of us are already aware on the harmful of coming from the chemicals, we have to think first whether it is good for the human welfare or make it balance between the value and the risk. I think we have to work for it to make it better. So keep going on doing research on chemicals, but before we release it, consider the benefit and the risk for our environment. That's, I think, my answer, Marini. Thank you.
Okay, thank you for all the speaker. Okay. So I will back.
Okay.
Okay. Okay. Okay. I've tried to conclude for all three speakers. Maybe we have enough time to make a presentation and then the answer and questions. Okay. First, from the Deemas, there's like a good difference between the mesozyme and then the thermozyme, and then it's like work depends on the temperature, and then for Deemas, the thermozyme is like already used in industrial because yeah, like in Pertamina they have like a working for the thermozyme, and then it's like can work at 40 and then 90-degree temperatures. And then for the Michael, for some questions, and then if we want to look up the intensive, like for the paddy, and then we have to look at the rice variety, and then for the crop to the other one, like paddy to the potatoes, and then to minimize the climate for that, and then we have to work by changing from production. So it's like related to the new climate, new weather, and then less for the work agriculture, and then food productions. And then for the green chemistry from Manihar, that's the green chemistry is one solutions for us to reduce the effect of the climate change, for example, and then the value of resistance of the water change. And then I will give to the MC for Nadia, and then to close this presentation or this webinar. Thank you, Nadia. I'll give it back to you. Sorry, we have to wait for Nadia because the Zoom is stopped.
if there is no more announcement, I think you can, Marini or Eli Julia can close the meeting, I think.
Nadia, are you there? Okay, I will take this. I will take this. Sorry. Okay, we are already connected to Nadia. Nadia, I will give you the time to close this one. I will give it back to you.
Okay. Thank you, Dr. Teh Marini Damanik. Okay, please. Now, I would like to invite the Vice Dean of Academic to deliver his closing speech. Ladies and gentlemen, please welcome Professor Herbert Sipahutar. Okay, sorry. Now, I would like to invite the Dean of Mathematics at Natural Science Faculty, Dr. Fauzia Harahap. Please welcome for giving the closing speech.
Okay, thanks very much for the opportunity, Nadia. Ibu Marini, Assalamualaikum warahmatullahi wabarakatuh. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, all of you, our panelists, this is Prof. Michael, Deemas, this alumni from Bilingual Chemistry, and then Professor Manihar Situmorang. Thanks very much for your information, your and then for Deemas, you have give information, many information to me, especially for me, and then for our in our faculty. Maybe next time you can join again to our seminar, and then I think the participants have many questions for all of you, but next time I will, and then Bu Marini and Bu Eli Julia can have any webinar again. Thanks very much for your attention, all participants, and then Prof. Michael, Prof. Deemas, and Prof. Manihar. We can say Alhamdulillahi Rabbil Alamin from our webinar, and then today we will listen deeper and detailed information from our resources. Finally, by saying Alhamdulillahi Rabbil Alamin, I closes the webinar Chemical Application Realizing Future Sustainability. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Fauzia Harahap, for the closing speech. Finally, we come to the end of the webinar. After the closing session, we will take a picture. Now, I will leave you with a quote by Stewart Brand, an author and innovative thinker, who once said, "We can see the past, but not influence it. We can influence the future, but not see it. Let's us all be guided by the old things that we have learned and heard throughout the webinar and be able to see and influence our future. To close this webinar, let's reciting Alhamdulillah. Well, ladies and gentlemen, please forgive us for our shortcomings. Thank you for all the contribution of all organizing committee. Thank you for all the speaker, and thank you for the all participants for coming and for your nice attention. Wassalamualaikum warahmatullahi wabarakatuh. Before leaving the online webinar, for our panelists and organizing committee are invited to take a picture. For the participant who want to take a picture, can click raise hand feature in Zoom application. Okay, we will take the picture. Okay, we can take one more by the character. Okay, like this.
Who takes a picture, Nadia?
The organizing committee, ma'am.
Okay.
Okay. For all the participant can participate too. Okay, you. Okay. 1, 2, 3. Okay. Thank you for the all speaker and for all participants. We hope we can see in the next webinar. Thank you, and I close again. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Michael. Thank you, Prof. Manihar. Thank you, Dimas.
Thank you very much.
Gak bisa lihat wajah-wajahnya. Banyak ini pesertanya. Yeah, we have a lot of participants there, but we can the page, you know.
Iya, partisipannya nggak dipoto, biasanya difoto juga. Nadia. Nadia.
Yes, ma'am.
Partisipannya di foto Nadia.
Baik.
Is it possible?
Possible, sir. Okay. For the participant, you can open the video.
We miss you all.
Okay. Please open the video.
Hostnya diminta untuk ini.
Right. Okay. I'm happy to see some of the page now, you know. I recognize most of them. I miss you all.
Miss you too, sir. Okay.
Okay, get the picture.
Okay.
Lagi dia.
Thank you very much, Michael.
Goodbye.
See you,
So I wish you a nice weekend.
See you in the
Prof. Michael.
Even.
I will send you an email with my presentation.
Right.
If you want, you can distribute it to the participants.
Yep, I already give it to the committee, and then they will distribute it to the participant, Michael.
Right.
There will be an updated version.
Okay, thanks a lot.
It was very nice to see you all. Pass my regards to your family.
Yeah, give my regards to your family too.
Aku tidak nampak.
Partisipannya mana Nadia? Minta tolong dihubungi hostnya.
Iya. So,
Yeah.
have you clicked the picture?
Yes, sir.
All right, right. So, can we leave now?
Aku aja nggak nampak.
Okay, maybe one more, sir.
Okay.
Okay,
Click to
please
the-
prepare for all the participants. We will take the picture. Give your best smile. Okay. Thank you.
Go to the next page.
Yes. Okay. Okay. Done.
Thank you
Thank you.
very much.
Thank you very much for the committee.
Okay, thank you very much, Deemas.
Oke, Mem Eli, Mem Fauzia.
Terima kasih semuanya.
Ya, alumni tahun berapa, Bu?
Manihar.
Marini.
2013 Bu, tamat 2013. Angkatan kedua bilingual Bu.
So goodbye to everybody.
Yes, thank
Okay,
you,
goodbye.
sir.
Goodbye,
It was
Profesor
nice to
Michael.
be in Indonesia.
Right.
Ya, main ke
For the next-
bilingual.
See you for the next webinar.
Thank you
Oh,
for
yeah.
the.
Right.
Okay.
So, can I leave now from this room meeting?
Oh, yes.
Okay.
Thank you, sir. Thank you, Mas.
Thank you, Prof. Thank you, Ma'am.
Thank you, ma'am.
Thank you.
Bye. See you in next session.
Assalamualaikum Nadia semuanya, Dimas ya.
Yes.
Izin
thank you.
pamit.
Okay.
Terima kasih, Bu Deka.
Terima kasih,
Ya, terima
ma'am.
kasih Prof. Terima kasih Bu Marini, Dimas
kasih.
semuanya.
Nah, tapi
Ya,
ada
Ma'am.
tadi yang kurang.
Izin
Kan Pak Rektor minta kan supaya bisa alumni mengisi research study. Mohon
waduh.
bantuan daripada alumni tadi karena kita butuh pemeriksaan.
Ya. Jadi Bu Marini,
Ya,
Bu Marini, coba ini kalau di Ikatan Alumni tadi jalan dia Pak Mardana dan kawan-kawan. Bu Marini kan ada nanti mau ngisi ini Google Form, udah ada ngisi Google Form belum teman-teman untuk sertifikat?
Sudah Bu, kemarin Marini sudah share apanya juga link Google Form yang untuk tracer study ke WA group.
Jadi mohon diinformasikan di sana supaya mereka mengisi link untuk alumni yang sudah kami masukkan ke WA fungsionaris itu Bu Eli, Bu Marini. Mohon disampaikan juga itu Dimas wajib ngisi Dimas ya.
Sudah Bu, sudah diisi,
udah ngisi. Terima
Share
kasih
juga ke
Dimas
angkatan
ya.
2 Bu. Iya Bu ya.
Ya, Dimas boleh
Isi, Bu.
share juga ke kawan-kawan yang adik-adik kelas juga lah ya.
Ya Bu.
Karena
Kalau
kita
angkatan
butuh
2
ini.
yang bilingualnya sudah Bu, sudah.
Oke, makasih banyak Dimas.
Ya,
Oh, ini teman-teman yang lain ini apakah ada yang alumni Unimed? Silakan ya diisi semuanya. Mohon di-share lagi Bu Warini, Bu Eli. Kami udah share kemarin tuh, yang kita share kemarin di fungsionaris. Oke. Ya. Terima kasih Pak WR4 atas semua masukan.
Ya.
Ya.
Iya Pak.
Ya.
Terima kasih Prof.
Udah lihat
Ya. Saya izin juga ya.
Baik Bu.
Ya.
Ya, makasih Bu Deka.
Terima kasih Bu.
Ya.
Pak Manihar.
Ya, assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh.
Hari ini ya.
Ya, makasih Pak.
Yes, ma'am.
Makasih, Prof.
Sir.
Makasih.
Terima kasih kepada semua partisipan juga.
Videonya mana Nadia?
Videonya, Mem?
Oh, belum jalan ya?
Oh.